Hello everybody! In this lesson I will discuss the formal proof of the cosine rule. Now before I can start with the formal proofs, I have to explain the sketch to you, and this is the sketch that you will use for all three proofs. Now first of all, you will find that you will work in a triangle ABC, and then once you are working in this triangle, that side, CB, you can call it little a. Side AC is little b, and side AB is little c. And A, since it is at the origin, that's the point 0, 0. B's coordinate is the point C, 0. And then C's coordinate there is b cos A, b sin A. Now let me explain to you where that comes from. That's the important bit. Now first of all, alright, the point C consists of a x and a y coordinate. And it works like this. There at C, you drop a perpendicular or an altitude to form a right angle triangle CA and whatever that one is. Then, when you zoom in on angle A in the right angle triangle, then you can say the cos of A is equal to, and cos's ratio is x over r. And when you make x the subject of the formula, you end with r cos A is equal to x. But in that right angle triangle, can you see that the hypotenuse is little b? So in r's place, you can substitute little b, and then there's your x coordinate. That is why x's coordinate can be written as b cos A. Then, for the y coordinate, you can say the sin of A is y over r. And when you make y the subject of the formula, you end with r sin A is equal to y. R is the hypotenuse. Therefore, b sin A is equal to y. That's the y coordinate. Now I'm going to explain the proof of the cosine rule. Again, it's the same triangle, given any triangle ABC. And you need your construction and you need the words. Draw the y-axis through A and the x-axis along AB. Then angle A is in the standard position and A's coordinate is 0, 0. B's coordinate is C0 and C's coordinate is B cos A, B sin A. Again, there's your perpendicular height. Now here's the proof of the cos rule. We start with the distance formula, and then you will know the distance formula as a formula that contains a square root. But what I did here was I squared both sides to get rid of the square root, and that is why on the left hand side it's CB squared. And then the distance formula, bracket x of c minus x of b squared plus y of c minus the y of b squared. And now we can substitute. CB is little a because angle A is in standard position. And then here at C, B cos A is the x coordinate and B sin A is the y coordinate. And at B, let me show you, the x coordinate is C and the y coordinate is 0. Now I can substitute, so I'm here. The x at C is B cos A minus, and the x at B is just little c squared, plus the y of c is b sin A minus the y of b is 0. Then in the next step, now on the left hand side it's a squared equals, and then you find a b cos a minus c, and you write that one in expanded form as 2 brackets. And then in the next step, the algebra that corresponds with that is x minus y, and that one, when you FOIL it out or you multiply it out, you end with x squared minus 2xy plus y squared. And I will show you that just now. What is happening here? B sin a minus 0 stays b sin a, but it's squared, and therefore in the next step you will give the square to the b, so it becomes b squared, and you will give the square to the sin, so it becomes sin squared a. Then back to b cos a minus c squared. As the algebra I've shown you there, it becomes a squared equals b squared cos squared a minus 2bc cos a plus c squared plus b squared sin squared a. And then in the next step, I'm going to rearrange my terms. So I'm just going to take the b squared sin squared a, and I'm going to write it there next to the b squared cos squared a. So that here I can factorize and I can take out b squared as a common factor. And I'm left with, in a bracket, sin squared a plus cos squared a plus c squared minus 2bc cos a. And then that is very familiar, since sin squared a plus cos squared a is your square's identity, which is 1. So in sin squared a plus cos squared a's place, I substituted 1. And now I end with a squared is equal to b squared plus c squared minus 2bc cos a. Well, that's the cos rule. But you have to add, by placing angle B in standard position, it can be proved that b squared is equal to a squared plus c squared minus 2ac cos of b. And by placing angle C in standard position, it can be proved that c squared is equal to a squared plus b squared minus 2ab cos of c. This is Miss Pythagoras signing off till next time.